This is Lecture 1, Variables, Hypotheses, and Two-Way Graphs. In this lecture, I will review the first steps in the research process, identifying a dependent variable and independent variables that may influence variations in the dependent variable. By the end of this lecture, you should be able to know the difference between an independent variable and a dependent variable, know the difference between small n and large n studies, know how to write a hypothesis, know how to graph the relationship between two variables by hand, know how to create a dataset in Stata, know how to open a dataset in Stata, know how to create a graph between two variables in Stata, know how to create a do file in Stata, and know how to use the help command in Stata. The first step in the research process is identifying a dependent variable. The dependent variable is your outcome of interest. For example, you may want to know why some political parties have a great deal of control over legislative candidate selection while other parties do not. Note that in examining this dependent variable, we are not interested in explaining how one specific party chooses their candidate selection procedures. If we were, that would be called a small n design, with n meaning number of observations. We would only have a small number of observations. Instead, we are interested in explaining how all parties choose their candidate selection procedures. We want to understand the general behavior of all parties, not just one specific party. This is called a large N design, as we would have a large number of observations. In addition, note that when studying variations in the dependent variable, this means we are examining different levels of the dependent variable. We want to examine parties that have weak candidate selection procedures, parties that have moderate candidate selection procedures, and parties that have strong candidate selection procedures. It is very important to look at all levels of the dependent variable when trying to explain why variations in the dependent variable occur. The second step in the research process is identifying independent variables that could influence the dependent variable. We believe that variations in an independent variable could influence variations in the dependent variable. We have to be specific about how we think the independent variable influences the dependent variable. We state that the independent variable has a positive effect on the dependent variable or a negative effect on the dependent variable. If we believe the independent variable has a positive effect, we believe as the independent variable increases, then the dependent variable increases. If we believe the independent variable has a negative effect, we believe as the independent variable increases, then the dependent variable decreases. For example, imagine our dependent variable was party control over legislative candidate selection, strong versus weak, and our independent variable was type of legislature, either unicameral or bicameral. We would say that variations in the type of legislature could influence variations in party control over legislative candidate selection. More specifically, we could say that parties in countries with bicameral legislatures have more control over candidate selection than parties in countries with unicameral legislatures. In other words, we would expect type of legislature to have a positive effect on party control over candidate selection. Bicameralism encourages parties to have more control over candidate selection. This statement here is what we call a hypothesis. I will now go over how to write hypotheses. A hypothesis is a one-sentence statement that describes how the independent variable influences the dependent variable. It tells us whether the independent variable has a positive or negative effect on the dependent variable. If the independent variable has a positive effect, then as the independent variable increases, then the dependent variable increases. If the independent variable has a negative effect, then as the independent variable increases, the dependent variable decreases. In addition, the relationship described in the hypothesis has to be observable in the real world. We should be able to collect data and determine if the independent variable influences the dependent variable in the way we expect. There are several different ways to write hypotheses. In the next few slides, I will provide you with some templates on how to write hypotheses. First is the more likely than / less likely than template. This template is useful when you have an independent variable that only has two categories and a dependent variable that also only has two categories. Note that when a variable only has two categories, we call it dichotomous, a dummy variable, or a binary variable. For example, your dependent variable was party control over candidate selection, and it took on two values, strong and weak. And your independent variable was type of legislature, unicameral or bicameral. You can use the more likely than template to write a hypothesis to describe the relationship between these two variables. You could write, parties in countries with bicameral legislatures are more likely to have strong candidate selection procedures than parties in countries with unicameral legislatures. Note that this hypothesis identifies how variations in the independent variable, unicameral versus bicameral, influences variations in the dependent variable, candidate selection procedures. In addition, we can observe this potential relationship between bicameralism and candidate selection procedures in the real world. We could collect data on these two variables to see if the relationship exists in the real world. The next hypothesis template is the more than / less than template. This template is useful when you have a dependent variable that is continuous and can take on multiple values, and an independent variable that only takes on two categories. For example, imagine your dependent variable is party control over candidate selection, and it ranges from 0 to 8, and your independent variable is type of legislature, unicameral or bicameral. You could use the more than template to write a hypothesis to describe the relationship between these two variables. Our hypothesis could be, parties in countries with bicameral legislatures have more control over candidate selection than parties in countries with unicameral legislatures. Note that this hypothesis identifies how variations in the independent variable, unicameral versus bicameral, influences variations in the dependent variable, candidate selection. In addition, we can observe this potential relationship between bicameralism and candidate selection in the real world. We could collect data on these two variables to see if the relationship exists in the real world. The last template is useful when we have an independent variable and a dependent variable that are both continuous and take on multiple values. It is the independent variable increases / decreases, dependent variable increases / decreases template. For example, imagine your dependent variable is party control over candidate selection, and it ranges from 0 to 8, and your independent variable is strength of upper chamber, which ranges from 0 to 1, with 0 implying unicameral and numbers closer to 1 indicating the upper chamber is strong. You could use the increases / increases template to write a hypothesis to describe the relationship between these two variables. Your hypothesis could be, as the strength of the upper chamber in the legislature increases, party control over candidate selection increases. Note that this hypothesis identifies how variations in the independent variable, strength of upper chamber, influences variations in the dependent variable, candidate selection. In addition, we can observe this potential relationship between strength of upper chamber and party control over candidate selection in the real world. We could collect data on these two variables to see if the relationship exists in the real world. If you are having problems determining whether you wrote an appropriate hypothesis, you could draw a graph based on your hypothesis to see if it works. This is most appropriate for two continuous variables. On the y-axis, you would place your dependent variable, and on the x-axis, you would put your independent variable. You should label the appropriate values on the axes and then draw the relationship between your variables based on your hypothesis. Imagine your hypothesis was, as the strength of the upper chamber in the legislature increases, party control over candidate selection increases. This is what the graph would look like. Party control over candidate selection is the dependent variable, so it is on the y-axis. Strength of upper chamber is the independent variable, so it's on the x-axis. And as the strength of the upper chamber increases, party control over candidate selection increases, resulting in a line with a positive slope. At this point, we will only be focusing on two basic types of relationships between independent variables and dependent variables. The first relationship is a positive linear relationship. As our independent variable increases, our dependent variable should increase. And this increase should be constant across all values of the independent variable. The effect that a change in the independent variable on the dependent variable is the same at low values of the independent variable and high values of the independent variable. In other words, the slope is constant across all values of the independent variable. The second relationship is a negative linear relationship. As our independent variable increases, our dependent variable should decrease. And this decrease should be constant across all values of the independent variable. The effect that a change in the independent variable on the dependent variable is the same at low values of the independent variable and high values of the independent variable. In other words, the slope is constant across all values of the independent variable. Now I'm going to introduce you to a statistics program called Stata. Many political scientists and other social scientists use Stata, and you will be using it in the graduate program at Boise State. Therefore, it is a good idea to get familiar with the basic functions of it now. You have access to the dataset I will use for this part of the lecture, so if you have access to Stata, you are more than welcome to use the Stats Review dataset to copy what I am doing in the lecture for practice. After you open Stata, you will see the Stata interface. In this slide, I will briefly go over the different components of the interface, and in the subsequent slides, I will go into more detail about these different components. This is the open file icon. It opens a data set in Stata. This is the data editor icon. If you want to edit your data set, you click here. If you just want to view your data, you can click here. This is the variables box. It tells you which variables are in your data set. This is the command box. This is where you tell Stata to run different types of statistics. This is the output box. After you run certain commands, the output is displayed here. The exception is graphs. Most graphs will pop up in a different window. This is the do file editor. This allows you to save all the commands you run on a dataset so you can reproduce them in the future. And this is the save icon. It saves changes you made to your dataset. If you want to start a new dataset, you need to create variables. To do that, you type in gen variable name equals period into the command box and click enter. Note that you cannot have any spaces in the variable name. So let's say I want to make three variables, country, year, and type of legislature. I would first type in gen country equals period and press enter. Then gen year equals period and press enter. Then gen type of legislature equals period and press enter. After you create your variables, you can click on the data editor. As you can see, your variables are in here. In addition, you can input your data here. So let's say for the first observation, I will have the US in 2016, and I will give it a 1 to indicate that it has a bicameral legislature. And for the second variable, I will have Peru in 2016, and I will give it a 0 to indicate that it has a unicameral legislature. Next, you can left-click on a variable name to view the variable properties. Note that a string variable, str, implies the variable is made up of words or text, not numbers. A float variable is made up of numbers. And whenever you make changes to your data set, save it. You will be saving yourself a lot of trouble in the future if you do. On a side note, whenever you create a data set, your first variable should always be the name of the subjects in your data set. It could be the individuals like legislators' names or countries or parties or whatever you are examining. The second variable should always be the year in which the data applies to. Now you can also open an existing data set in Stata. Please note that if you have a data set open and want to open a new data set, you have to first save the data set you have open, then type clear into the command box and press enter. Then you click on the open file icon and you select the data set you want and open it. I'm going to be using the Stats Review dataset. Note that if your dataset is too big to open, in the command box, type in set mem 100m and press enter. Then you can try reopening your dataset. Now I'm going to show you how to make a graph in Stata. You click on the graphics button, then you click TwoWay. You click create. You choose your plot type. You choose the appropriate y and x variable. Remember that the dependent variable usually goes on the y-axis and the independent variable goes on the x-axis. Then you click accept and OK. I'm going to use the Stats Review dataset to show you how to make a graph. I'm going to put candidate selection on the y-axis and strength of upper chamber on the x-axis. I will choose the scatter option, click accept and OK. Here's the graph. Note that you can copy this graph and paste it into Word. You can also edit your graph in the graphics interface. First, you want to click Start Graph Editor. You can click on the title of the y-axis and put the appropriate name on it. You can also click on the x-axis and put the appropriate name on it. You can also add a title by clicking Graph Titles. And when you are done, you can click out of the graph editor. You can either save your graph or not save it. I'm not going to save it. And then it'll be here. And then you can also copy and paste this into Word. Note that there are several more options with graphs that I will not go over in this lecture. With Stata, you will learn to do a lot of cool things with graphs and other Stata functions on your own through trial and error. Last, notice the code in the output box. This code created the graph we just made. Eventually, you will remember this code and you will be able to bypass the options up here and write the code down here yourself. You enter the code into the command box and press enter. If you want more information about what the code does or more code options, you can type in help and then the name of the topic into the command box and press enter to get more information. So, if I want to know more about graphs, I can type in help graphs into the command box, press enter, and a help window will pop up with more information. Also note that you can save all of your code in a do file so you can replicate what you did later. So you click on the do file option. You can either open an existing do file or start a new file. I'm going to start a new file. You type in the code here. I will type in 2 lines of code for 2 different graphs. You can make comments in a do file too by typing in between a /* and a */. Stata will ignore these comments when you are running your do file. You can tell here because the text is green. You would insert comments here so you know why you ran certain commands, or so you know in the future what those commands did. You will eventually be running very complicated commands and you may not remember what they did. So comments are very, very useful in do files. After you are done writing your do file, you can run your file here by clicking this button. The button is the one that looks like a page with written text on it. That's how I remember it. I don't know if you noticed, but 2 graphs popped up. However, in Stata, only one graph can be open at a time. So if you only want to run part of a do file, what you do is you highlight the line of code that you want to run, just select that part of it, and then you click this again, and it will only run that part of the code. As always, when you are done with your do file, you should save it so you can open it later. And this is the end of lecture 1.